Hi everyone. So good evening. Sir, good evening. The-
Good evening, sir. Good evening.
Good evening, sir.
Nice to see you on the.
You go ahead with your class, sir.
Okay, sir. Thank you very much, sir. Dear students, Dr. Panigra is the deputy director of IGNOS. He is in the line right now. You can see him. So everyone, you can wish him. Right. Good evening.
Good evening, sir. Hi, how are you?
Good evening, sir.
Okay, sir. Just left and hope you all are enjoying the day. And it's winter. You all are in the hot that clothes. Okay, so but somewhat here the temperature is somewhat high, so that's why we are feeling not that much cold and all the things. Okay, that's fine. So today is the last lecture of unit 1, and after this I'll finish the unit 1. Also we'll start the unit 2 today itself. So but the last part of the unit 1 is very crucial, that till what I taught you, that is exactly what are the procedures are there, how the techniques are associated, what type of techniques are used in this case. So that is all I explained in this last 2 lectures. But today it's the real practical things. What are the practical things? We will not do any kind of practical today, but we have to understand how important is what is the how the procedures are most important. So what kind of things you have to do, what type of procedures you have to maintain to test something. Anything means any kind of misconduct, mismanagement, you can say in the general English, or you can if any kind of that is malfunctions you will use, or proper technique if you will not maintain, proper sampling you will not do. So that means you will be failure in case of experiment. And a failure of experiment will, I told you, when you use the sample, Raman spectroscopy do not, but that particular does not, Raman spectrometry method, that does not damage the sample. But if you use any kind of a reagent to the sample in other process, so that sample will be destroyed. It's just crucial. So when the technique is coming and application of a technique is there, use of a technique is there, you don't have much more sample. I told you last lecture, yesterday also I told you, you have very few small amount of sample, and it is very essential to understand how you have to use the sample. Yesterday I also told you regarding the radioactive elements. If you are thinking about there is possibilities of finding out by the finding of any kind of a radioactive elements or a decay, so that means you have to use the nuclear process, nuclear method of analysis. So that's why it is very difficult. In very beginning of my lecture I told you analytical chemistry is most important part of a chemistry because it is practical. Everything you have to do under some precaution steps. You, before doing anything else, you have to think 1,000 times what you are doing. Is the procedure is correct? Is the equipment what are you using it is the correct? Is it the perfectly you have follow the steps before doing the practical? You have to analyze 1,000 times doing before doing the experiment. It is not the thing that will come and put something and I will do the experiments. It is not possible like that, because you are at that stage, you will guide the whole world, whole chemistry departments. Among out of you, that maybe some scientists will be coming out within very that short span of time. You may be the good that is stakeholder of an organization. You can give your best in the pharmaceutical industries. You can give best to the ISRO. You know that space research. If you're part of the ISRO, analytical chemistry person, that working in ISRO and NASA. You know that how much that investment is there in this space research organizations. So one little bit of mistake, if I'll say something that you have seen that movie that is Manglayan and all the other things, Hindi movies are there. That is most motivational movies. That particular movies help us to find out that how we'll not make a single mistake. A little mistake put you in danger condition, put the organization in the danger condition. So the growth of the organization, growth of any kind of field where the analytical chemistry is used, and I perhaps after my 2 lectures you can understand where that you cannot use the analytical chemistry. Everywhere, every sector, it is maybe that 100 times, maybe 10 times, maybe 1,000 times. It depends upon the ratio and all the things, how the mechanic things are going on inside that particular organizations. So that's why today's lecture is most important. That last 2 lectures we have gone through the different processes, how the processes, what is the principle, what is the technique, where it will be the application of that particular process. But today the practical things, when you do the practical, you have to think 1,000 times that what I taught you in the theory paper. Okay, wish you all the best for this lecture. To me itself also, because this particular things is, you have completely that practical things. If you are in my lab, then I can show you how to do, but theoretically to explain these things is very difficult, right? In lab I can show you, I can teach you, I can tell you anything else, right? This, how can you manage all the things, but in case of that particular in the process of theory class, so it is very difficult for me and for any professor to explain the practical in theory basis, on the basis of theory. Okay, whatever maybe, I'll try to support you and help you. I'll give my 100,000 times of my potentials to explain all the things. So now we'll go to the lecture. Okay, so now everyone, can you tell me that I just share my screen with all of you? Are you able to observe that screen or not?
Yes, sir. Yes, sir.
Okay, that's fine. That's fine. Okay, so this is the end of the unit 1 and we'll go to the lecture. Okay, thank you very much. So now the slide is that. Now see, the heading itself, if you have seen your syllabus, which is provided from IGNO side, okay, so you can see now the heading, the criteria for evaluating the utility of analytical techniques. It's actually, if you think about this particular phrase of words, it has a big meaning in case of chemistry. Being a professor, if I'll think itself, so it is actually a hilarious matter for me. So you are the students, because you are not customized with this field and you have not seen the lab and all the things. Okay, what are the labs you have seen, and what lab you will see now in the near future when you'll do any kind of things in the analytical chemistry. So you will see that particular lab. Okay, so now the thing is that criteria for evaluating the utility of analytical techniques. What techniques we have already followed in last 2 classes, that utilization of that property and evaluation of, our motto is to find out what is the amount present in that particular compound. If we say that I have to evaluate, suppose from cadmium chloride I have to evaluate cadmium, from zinc oxide I have to evaluate zinc. I'm giving the simple examples because you have already learned these things. I have to evaluate oxalic acid, what is present in that particular solution. So you have done this process. So the meaning of this statement is, I no need to say that what is the English meaning of this statement, but I have to say from chemistry point of view, what is the meaning of this particular phrase of words. Criteria for evaluating the utility of analytical techniques. What techniques we have observed, we have followed in the last. If we take the example of that is mass spectroscopy, chromatography, or Raman spectroscopy, whatever you have read in the last two classes, what type of a procedure you have followed over there. So that particular things where you have to utilize, how you utilize, what to do. For chromatography, what steps you will follow. Same steps is not equal when you are following that Raman spectrometry. Or same thing when you will follow that in case of that a nuclear particular nuclear elements or radioactive elements are present. All techniques are different. So that's why this particular steps, the last part of this unit is very important. It is really the practical things. Really, you have to understand the things. Okay. Now the things has come to the point. Okay, let me to go to the slide. Now, today, with the help of the newer techniques, what techniques we have read in the last chromatography, then mass spectrometry. So whatever the techniques that we have read in the last yesterday class or last class, so such as mass spectrometry, NMR spectroscopy, high performance liquid chromatography, etc., the structure of elucidation has become more perfect. Do you understand the thing? That techniques, the modern techniques, what we have, classical techniques we have read in the last year, that is whatever magnetic separation, leaching, that particular roasting, that is separation process. We can separate from one compound to another compound. But right now, what will happen? We are not separating that thing. We are studying the molecular structure, bond strength, and what are the elements are associated with this one, how they have behaving. This type of behavior we have to study right now. Right now, modern technology telling something like that. We are not studying. We are not studying how to separate. Separation is essential, but with separation, we have to change the direction, that we have to understand how the molecular structure of the compound is there. If we think about that, yesterday I told you methyl chloride. If you say, what is the structure of methyl chloride? Methyl chloride is usually, when I'm theoretically, I told you methyl chloride structure is tetrahedral. Tetrahedral structure. Geometry also tetrahedral. It's simple thing I told you, geometry is tetrahedral, but actually I cannot say you where the hydrogen atom is there, where the carbon is there, where the chlorine is there. I don't know. How can you say in theory? It is not possible. We have to understand practical. Where is the hydrogen? Where is carbon? What is the angle between that? What is the length of bond? We last few years, what I taught in class, we don't know. That is actually we have read that is 181 picometer of length in the what is that methyl alcohol, carbon and oxygen bond. There is 181 picometer. But it is theoretical. Someone told us. Some scientist founded that, and inform us that it is there. We just refreshing our mind and memorizing that thing. But right now, we are not going to memorize anything. We have to find out what is that. What is the bond length? What is the bond angle? We have to find out. We will make that is particular point. We will break down that key point. What is the bond length? What is the bond angle? What is the bond strength? What is the bond order? We have to crack down that out by studying this analytical chemistry. That's why it is most important. So, thing is that I meant to say that what is the importance of what subject you have chosen, what subject you have chosen, and which paper you have chosen. So, how important is in your life. This is actually being a chemistry person. I told you it is actually you, the people are the correct people, those who have chosen a very good chapter. That is, that I should thankful to the IGNO. They have introduced this chapter into the analytical chemistry. I should thankful to the government of India also, because they accepted these things. It is not easy one, right? And you people are much more. That is, you should be get the appreciations that you are taking part of this particular subject. It's fantastic one. For me, it is great chapter, great subject, analytical chemistry. So okay, that's the different thing. But the thing is that as we are the part of this subject, I don't know that most of the out of you that are part of the any kind of organizations, your professional studies essential. That's why you have to understand what is that. So that's why you will grow your career, and in case of this particular area. Okay, now the thing is that, so I told you the structure elucidations and has become more perfect by using this NMR, mass spectrometry, and all these analytical techniques. Okay, utility of analytical techniques is to be found in various fields as the key to the solution of a variety of scientific problems and industrial problems. Okay, now the things you have to understand this. This, see that I have to segregate one particular thing from a sample. I have to segregate. If you take the example, the people of that is Institute of Life Science of Government of India, that ILS, they have done a marvelous job during the COVID. They have actually that they have segregate that particular that virus from the and all the DNAs from the particular that virus. So this is a process, analytical process. How will segregate that DNA? It is a difficult job. It's not simple one. We should thankful to that scientist, and one day you will be. Okay. So this is the techniques that where you can utility of analytical techniques is to be found in various fields as the key to the solution of a variety of scientific problems and industrial problems. Okay. In order to understand the criteria of evaluating the utility of analytical techniques, it is useful to identify the several steps in performing quantitative analysis. A complete analysis actually consists of the following main steps. So that means, see that we have some steps. We have to follow the steps very clearly, very minutely. We have to follow the steps. That's why that is most important. That's very beginning of my lecture, of the end of this unit 1. I told you this area is very honestly, I told you this area is very important for you only. Those who are making their career, they're doing their job in the analytical chemistry field. Okay, so what are that? What are the steps we have to follow, and we have to that ensure that these steps should be followed correctly. Sampling. So then I'll discuss each and everything in next slides. So first, the step is sampling, then dissolution of the sample, separation of the interfering substances, measurement, interpretation of the measurements. And the most important point is there, often beginners carry out usually step 3, 4, and 5 for the sake of the convenience. Okay, so often the beginners carry out the usually steps 3, 4, 5 for the convenience. Okay, so this is the thing. Next, we'll go to the next slide. Next, this slide, this thing is most important and the first step of analytical chemistry. This is the first step, sampling. Means you have to prepare sample. That okay, slide is written, the theory part is there. Okay, I right now I'll tell you that you have to prepare the sample. Suppose you are doing titration. For example, as you are well customized with the system of titration, I told you, suppose you are doing the titration, what to do? That solute will, that what solute is given, that will be properly dissolved. If residual part is there in the solution, and you will add to the chemical, then what will happen? if your that suppose if we take the oxalic acid and it is now in the lab, it is available in the crystal form, you'll put in the water and you'll preparing the oxalic acid solution, but the residual part is, it is not immediately, it will dilute, so it will take some time. So stirring continuously is essential, and to make ensure that all the crystals of that oxalic acid is properly dissolved in the particular water, and a perfect solution will be there, and should be that amount. Suppose I have to put 3.14 gram. You have a waste machine. Okay. So what will happen? Suppose let us consider in half liter, I have to put 3.14 gram of oxalic acid. Anyone have prepared that oxalic acid solution in the lab? Out of you, those are joined in the class. My question is to all of you: have you ever prepared that oxalic acid solution?
Yes, sir.
Okay, good. No, don't feel bad here. So that is not essential. Don't feel bad. Don't see that if you communicate properly, then that I am a professor. You are my students. Okay, maybe you are working person or something in the field of mastery there. I have to learn something from you, and you have to learn more from me. That is the point, because I know in the chemistry field I know much more things, and you know less in my point of view, but I something maybe there I have to learn from you, because if you are working in the practical environment, I don't have that idea in that particular pharmaceutical company. I don't have any idea. Suppose let us take that. If you are working in the space research, I don't have any idea in the space research. So you can tell me, you can give me some ideas and all the things. That is your, what is that? That is your communication point. Okay, so that if my question is, see, don't be hesitate, don't be means feel that if if will say I don't know, then sir and other people, those who are in the online class, this is the all India class. Okay, so I don't think so. Education is a point where we can exchange our knowledge. I know much more thing in chemistry, but I don't know all the things. Do you understand what I'm going to say? You can say, I know 99.9%, but 0.1% I don't know. That is my lacuna. Maybe that 0.1% you know, you people know. You can guide me. So that is the thing. Exchange policy should be there. Okay. So being a practical subject, so if you prepare that oxalic acid solution in the lab, have you ever done or something else like that? If there is, okay, now I will come to the point. So at your home, you can prepare, you might somewhat prepare that lemonade water, right? Lemonade. So lemonade drink. Within that, you'll put some salt, sugar according to the choice. If it, that diabetic patient is there, you cannot put the salt. You can put the sodium chloride, common salt. Okay, sugar you cannot put, but salt you can put. Okay, whatever the conditions. But if that, my question is, if the residual part of the sodium chloride remain on the base of that particular glass, so if we will provide that one to someone else to drink, so at the end, what will that? The concentration of the sodium chloride will be high. So the behavior of that particular thing will be, what will happen? That will be not good in the experimental point of view. So that's why I'm telling you, preparation of sample is the most important area of this analytical chemistry. That's why this slide is there. Okay. So my point is that you have to understand that one. If concentration will be high, then rate of reaction will be high. If concentration remain constant everywhere, then rate of reaction will be flow accordingly. So sampling preparation is the most important. So you know that your career and all the things, your which segment you are working, what type of a job that you are providing in pharmaceutical or in environmental chemistry, or in case of that is your what is area of agriculture, area of industries, what kind of industries, whatever there. So on the basis of that, you have to prepare the sample. Okay. Now the sample preparation on that. In analytical chemistry, sampling is the process of taking a part of a whole for the further analysis. See, perhaps you have, all of you have done the salt analysis, right? You have done the salt analysis in your lab in your 10+2 or graduation, you have done the salt analysis. So that unknown salt is supplied to you. You have to take a pinch of salt for the experiment. Whether that particular, maybe your experiment is that for the first time when you taking and reagent will added, maybe that salt give the positive result or negative. You have to note down that. So sampling is the most important area. So now the thing is that what will happen? Small amount of that is from whole you have to take. It is a critical step in the analytical process and is the responsible for the representativeness of the analytical result. So the statement says the importance of the analytical chemistry sampling. So you have to take a small amount of salt from the sample, then accordingly you have to do the experiment. If you will take whole salt or whole things, whole sample at a time, then your work is over. If you fail, then work is over. You cannot give. You will not get much more that is sample anymore. You will not get the sample. So wisely use the sample. Okay. Next, it does not mean that you will success. It does not mean that you will be get all the results at a time. So that means sampling, taking of sampling, use of sampling is the most important part of the analytical chemistry. Next, sampling is important in analytical chemistry because it allows analytical chemistry to have a workable size. Okay, small amount. You cannot take much more size when the target population is large. Or see, what is the meaning of this one? I am telling you. If your area of experiment is more, means it is completely unknown. You don't know anything else. You don't know what is the behavior of this particular sample. So that means the work system will be more. Steps will be more. You have to follow several techniques. So that means you have to use lesser amount of a sample. So that's why you can use a large population or area will be vast. You may use Raman spectroscopy, you may use mass spectroscopy, you may use chromatography, you may use multiple dimensions. You may use. So that's why using a sample is essential. You don't know what kind of a procedure techniques will give you the result, positive result. You don't know. So that's why. So using a sample is most important, and it is for your practical knowledge. This is actually, this thing will help you. This thing will help you in the lab. This thing will help you in the practical, in the in the work area. So theoretical knowledge is okay. I may go for the memorizing all the things. I can so ऐसे बोल सकते हैं, we can go for the by heart, making by heart, we can write down. But practical, where is the practical? So analytical chemistry, very beginning I told you, this is the practical things. So be careful about this one. Okay. Next. So a smaller sample decrease the uncertainty and chances of error while undertaking the analysis process. The sample preparation is an essential part of the chromatographic and spectroscopic analysis. As you know that your actually this particular unit, you have to focus. I told you have to focus on the modern techniques like chromatography and spectroscopic methods. This is the particular things we'll read in this particular unit, okay, or coming unit. So that's why that sample preparation in case of analytical chemistry is this particular 2 methods or 3 methods, whatever, it is important. The purpose of a sample preparation is to convert the sample into the form suitable for analysis without significant loss or target of the compounds. Okay. Sampling techniques may be quite different in different cases. Okay. So that is why. So you see that you will point is it's in front of you. So for every technique, we cannot use a particular sample. Similar type of a sample preparation is not used for each and every techniques. For chromatography, preparation sample is different. For spectroscopic, preparation sample is different. So that's why you don't know which technique will help you to get the result. Experiment will be success on the basis of that techniques. So which technique will give you the success, you don't know. So that's why preparation of sample is most important. But after that, you you can get a success. Okay. Next is that thing that so sampling techniques may be quite different in a different cases. Each type of material has its own special sampling instruction. What I told you exactly, which take into account the specific characteristics of the material, the quantity taken, its purpose, etc. Okay. So that means that's why this process is most important, sampling process preparation. Okay. Next slide. We'll go to that point. Next slide. Now see that in front of you there is a diagrammic that a picture is there. So one side it is written steps involved in a measurement process. Second side it is written that steps involved in the sampling process. So measurement and sampling. Once sampling is there, as we are discussing about the sampling, so measurement will come. So on the basis of that, in the measurement, first sampling is there, then sample preparation is there, then sample preservation is there, then sample preparation is there, then analysis is there. And steps involved in the sampling process is identify populations. Second is collect samples. Third is reduce gross sample to lab sample, analysis sample. Okay. Now the thing is that, so I told you, so that is in the last class also I told you that if some sample is coming from the from any source, size is suppose it is from what is ore type, from that is ores and all the things. Okay, that mines and all the things, from that sample is coming out. So it will be a huge amount. You had to select the sample. So everywhere that particular, suppose one iron ore hematite, last also example I told you in the last lecture. So if hematite ore is in front of you, it is hematite ore. Iron is there. Okay, but where exactly iron that elements is there, so that is the importance, that is the thing you have to find out. So preparation of sampling is important, right? Okay, then you can calculate that particular iron, that particular mines containing what is the percentage of iron over there. Neither it is the cost effective. If you not calculate, the company will lose all the things, and you know that loss and profit gain. Okay, so that means it is everything is in your hand. Okay, now we'll go to the next slide. Let us understand. Second, first is the sampling. Second is dissolution of the sample. This is another important steps in that analysis of what is that particular preparation, what is that thing is there. So it is another step. So in analytical chemistry, sample dissolution is the process of mixing a solid or non-aqueous liquid sample with water or mineral acid to create a homogeneous aqueous solution. See, all of you know that homogeneous and heterogeneous solution. If that is particles are uniformly mixed, there is no residual part in that case, so it is homogeneous. If it is that is not uniformly mixed, so it will be sedimentation. Sedimentation is there or in the below that some macro particles are there. So this is actually that heterogeneous solution. For the sample preparation, homogeneous mixture should be there. Means it should be that what type of, if we put that the sodium chloride, I told you the homogeneous mixture, if we put the sodium chloride in water and stir it, so you cannot, by looking at this, the water solution, you cannot say whether there is a salt or where there is a sugar. Okay, so where there is salt or where there is sugar, you don't understand until unless you go for the lab test or your chemotherapy test. Means your chemotherapy in your tongue, right? There chemosynthesis. After that, you can test it. If it is salty, then you can tell that common salt is there. If it is sweet, so that means you can say that it is that sugar is there, right? So that means the taste depends upon that. On your tongue is a chemosensitive part, so that's why you can give the taste. Until unless if you see 2 glasses of water, there one is I'll add sodium chloride and another solution I'll add that sugar and put in front of you. I'll say that solution A, what is solution A and what is solution A? You cannot say because it's a homogeneous mixture. It is homogeneous mixture. That's why you cannot say that whether it is a salt solution or sugar solution until unless you will go for the any kind of a chemical test. Okay, so that means that sample prepare this solution is the homogeneous aqueous solution. This solution allows for subsequent separation and analysis. Okay, as it is a homogeneous solution, so that means we have to follow some steps for the analysis. This is what you say the separation of that is 2 things or 3 things separately will bring out from each one each component from that particular solution, that is known as dissolution. The dissolution of inorganic sample, this is important. Inorganic sample, this dissolution of inorganic, this is specific. The dissolution of inorganic sample usually involves preparing an acidic aqueous solution from the test person. Okay, so if it is inorganic sample, if you think that is inorganic sample, so that means you have to use an acidic aqueous, you have to make it acidic aqueous solution. So that means acidic aqueous solution. So that solution should contain acid and water. It's acidic aqueous solution. Okay, so this is for inorganic salt. That's why this I will come to the next thing. So if that is a particular process for inorganic, you have to make acidic aqueous solution. The most common approach is to directly applying 1 or more mineral acids. You can add. You have seen. You have done the salt analysis, that minor salt analysis like ammonium chloride or anything else. You can have to add 2 that is acid, sulfuric acid along with the hydrochloric acid, concentrated dilute. Okay, nitric acid. You can have to add. So that is the area. So you have to understand what to do. Okay, if dissolution is the process of the solute in gaseous, liquid or solid phase dissolving in the solvent to form a solution. Sample dissolution procedure can be divided into dry ashing and wet digestion methods. So 2 methods are there. So we have to understand these 2 methods. Reply, what is that? Just a second. Just a second. Someone has some issues. Okay, no. Okay, good. Okay. Now the thing is that, so let's go to the next slide. Okay, see, this is the sampling. How to dissolution will be done. In this case, this is the picture. It will be elaborate something. Okay. Now the separation of interfering substances. Okay, what is that? Interfering substances. See, let me to tell. Actually, you will understand that thing. Have you heard about have you heard about the azeotrophs? Can anyone tell that azeotrophs? Anyone do you know that azeotrophs? Yes or no?
Yes, sir.
Okay.
So in case of azeotrope, if distillation, if 2 liquid is separating by distillation through boiling point difference or volatility
this is
difference.
actually that a boiling point. That is very good. That terminology is important. So boiling point,
Yes,
if thank you, Mr. Dibbendu, thank you. So if that is in the boiling, if actually I am telling you one fact. So water, that boiling point of water is 100 degrees Celsius. If we add alcohol, ethanol to it, so ethanol having that boiling point is 85 degrees. Okay, 85 degrees Celsius. When you add together, there will be intermolecular force of attraction. What is that? Because ethanol is consisting of hydrogen bonding OH bond, and also that water is also containing OH bond. Then what will happen? Due to the intermolecular force of attraction, the solution have the boiling point around that 95, 93, 94 degrees Celsius. So in that case, you will use that particular temperature, means heat distillation process. So you cannot get that. That is the fractional distillation process we have to use. So the thing is that, so this is the interfering substances. This is the interfering.
Sir, if any fractional distillation, then if we reduce the boiling point range, then we add another
Okay,
solvent
that is
outside.
the controlled boiling point. That is control boiling point process. That will
Yes,
happen. Yes.
Yes, sir.
If you can make up to the 85 degrees Celsius, then it will be dissolved. Very good. So that is controlled. Okay. So what are the actually fractional distillation is that one. Fractional distillation is that one only. You have to means fractionally you have to check it out. But a boiling point control, you will make 60 degrees, 70 degrees, 80 degrees, then 90 degrees, then 100 degrees. So like this process, you have to control the boiling point. After that, the separation will be out. So that is the process. Okay, very good. So this is the interfering. So that is why it is called 1-2 process as a maximum boiling point azeotrope and minimum. I told you that what you have already learned in your previous classes. This is the example I am giving you. Okay, but what is the analytical process you will face? That's lots of interfering substances will be there. Processes will be there. What is that? Let's see that. So that the interfering substances are the compounds or elements that prevent the direct measurement of the species being determined. So therefore, before an analytical measurement can be made, it is usually necessary to solve the problems of interference by their separation from the analytes. See, suppose I'm going to say from zinc carbonate, suppose from zinc carbonate I got the zinc oxide. Zinc carbonate is the ore, I got the zinc oxide. Zinc oxide is also ore. But I don't understand that whether it is zinc oxide or not. So I measure that mass of that. That is wrong. Which oxide is there? That is interfering substances. That element is there. We have to separate it out from that. So that's for that chemical reaction. We should understand the chemical reactions also. So once you got zinc carbonate, that from zinc carbonate you got zinc oxide, then zinc oxide, from zinc oxide you have to separate it out the oxygen. So oxygen here is the interfering substances. We have to remove that one. Then we can get the particular amount. So that's why that is the understanding things, what to do. Okay. Now the thing is that, let's go. There may be two ways in general to achieve separation. First one, by isolating the desired constituents in a measurable form. Second one, by removing the interfering substances from the desired constituents. These two processes are there. By using these two processes, you have to separate it out. Here are some methods for removing interfering substances in analytical chemistry. Okay. Now the thing is that we have to go to some specific processes to remove this the interfering substances. That is selective precipitation. What is selective precipitation? Actually, some reagents are there, some species are there which can segregate the things. Like I told you one thing. If zinc is there and HCl is there, I have to bring out the hydrogen. I have to calculate the hydrogen. In zinc is there and hydrochloric acid there, hydrogen is there. I have to calculate how much hydrogen gas is present in that particular amount. Suppose I have used 10 ml of hydrochloric acid. I have to calculate from 10 ml of hydrochloric acid how much hydrogen gas is coming out. How many? Just a second. So how much hydrogen gas is evolved by this reaction? By using 10 ml or 20 ml or 30 ml of HCl. Then what to do? I have to use zinc. Suppose this is a one process. You have lots of process. I have to, in hydrochloric acid, I have to react, zinc, I'll react with the hydrochloric acid. Then what will happen? The amount of that hydrogen gas will be evolved because the precipitation is formed the zinc chloride. it will remain on the bottom part of that particular that test tube or whatever the equipment you are using, and hydrogen gas will be evolved. How much hydrogen gas is evolved? I have to measure that one. Don't think that is gas. How can you measure? Yes, you have to measure the gas also. Substances will form the solid, liquid, gas. We don't know. What you are going to see, suppose you are working in a particular that industry where you need the hydrogen gas for formation of hydrogen peroxide or something else, whatever. You need the hydrogen gas. Then you have to do the reaction. You have to calculate 10 ml of this hydrochloric acid give, suppose that is 1 gram of hydrogen gas or 1 ml of hydrogen gas. Then you have suppose 1000 ml of hydrochloric acid on the basis of that same concentrated hydrochloric acid. So that is the thing. So sampling is the most important, and here that precipitation is formed and interfering substances is there. Okay. Next, it will go to that. So there may be, okay, so here are some methods. So selective precipitations, that is the, or reagent is added. I told you, or reagent is added to form an insoluble compound with the interfering ions, removing it the solution. I told you, what example I told you, that is actually the real example of a selective precipitations. Very honestly, I told you, lots of selective precipitation processes are there. But I told you one thing. So this process is a very, very common process. What you have done, you have to that selective procedure means hydrochloric acid. You want to, but that is find out what is the amount of that in 10 ml of what is that hydrochloric acid, how much hydrogen gas will be get, or will what is the amount of hydrogen gas will be formed. So that is, then we'll put the zinc. You can use any other things. Okay, so then lots of procedures are there. So thing is that you have to use the selective method, selective procedure. Which one is going to do what? You have to understand that one. Just a second, please. Okay, so that is the selective precipitation. Precipitation will be there. It will placed on the bottom part, and another part will be separated out, and we can collect that on, and we can calculate also. That is the selective procedure. Next is that, but this is the, but this step is why, what is the important, what kind of a reagent you will use. So that is most important. What kind of a reagent is you have to use. Next is masking. So this is very actually this is a very good process. A strong soluble complex is used to bind the interferent, so preventing it from the interfering with the analytes determination. Okay, so this is the masking. So it will be supposed to be, actually this terminology is there, mask, right? So it will put a cover on it. Actually, see that I am telling you one thing. That two things are there. Suppose if you have idea about that detergent, okay, detergent, how the detergent works. So that is the point. Okay, so that your clothes and your what is the dirt, between that there will be interfering layer. So that is masking. So cloth will be separated by the detergent from the, that is your dirt. That is masking. One complete area will be there. Suppose you know that in the rain you hold the, what is that, umbrella, or we are wearing that what is that raincoats. Okay, so that is the masking. So like that, there is a separation layer will be there, which can separate it out both the two things. Like between oil and water, there is a that is a surface chemistry, but that is a masking area is working. Okay. Next is that protein precipitation, a method for selective separating proteins from other contaminant. This method involves protein precipitation by TCA or acetone followed by the resolubilization of the electrophoresis sample buffer. So you know that last class I told you electrophoresis means that separation by using the charge, means when electrical field will be there, so charge particle will be separated out. That is electrophoresis, that process. So this is the protein separation, protein precipitation methods where you can use this one also. Okay. Next, we'll go to the next thing. That is, now another important point in this case of analysis is measurement. Okay, so measurement is another method. See, you know that I also told you what kind of units are used. That is in for people that using any solid, that kg, gram, milligram, microgram you can use. If you are using that any liquid, that liter, milliliter, or that micromilliliter, whatever the units you use. So for the length, mass, time, volume, concentration, pressure, temperature, energy measurements are used particularly in the analytical chemistry. The established procedure must be followed carefully in individual quantitative determinants. So equal care must be taken in the choice of suitable techniques for the desired determination. If you think titration, it should be in liquid form. Titration cannot be done in the solid form. If you think about that spectroscopic method, it needs to be in solid form. I'm not telling about the spectroscopic titration. I'm telling about only the spectroscopic method. It should be in the solid form. Like I told you if you go to the jewelry shop nowadays, that ornaments will put inside the spectroscopy meter, and you'll see the purity of that one. That is your job. Okay, so that particular things are there. The success or failure of an analysis is often critically dependent upon the proper selection of the methods. See, if you are doing the titration and you are using the solid, so you know that your method, your principle, your experiment will be success or not. If you are using spectroscopy and I'm telling you, you are just spectroscopy, are using that liquid, so that's your method will be success or not, that technique will be success, your experiment will be success or not, you know better. So you have to understand what to do. So that's why in the very beginning of my lecture I told you, so everything should be in a proper step. Proper steps should be followed. Definition should be there. SOP should be there. What to do. So before doing anything else, my suggestion today itself, I told you, before doing anything, you have to think 10 times, 15 times. If that experiment is new for you and nothing have done, you are the first time you are doing simple things. Being an IITian, I told you, we have done several experiments. We don't know what is the component there. We have when I did my PhD, so that time we were experimenting, we are doing the experiment in newer substances. We have to record all the things. So it is not easy one. What to do? So that's a sample size is most essential. So practical, as you know that you are taking part in this syllabus is that like that. So analytical chemistry. So it is the practical things. So you should be careful about this. Okay. So now we'll come to although no simple rules can be prescribed. See, for the measurement, there is no rules. You know that for liquid, you are using that volume of the size. Volume should be in a liter, milliliter. For that solid, you are using that is what is your kg, gram, milligram, right? So the pressure you use ATM, bar, torr, etc. Temperature, Fahrenheit, so degrees and Kelvin. But be careful. Always my advice for temperature, Kelvin you should use. You should use Kelvin, right? Okay. So but that is the things. Okay. For energy, you can use joule, kilojoule, right? So what type of, there is no specific rule for this one. Okay. You will say that sir, can I measure the liquid in kg? Absolutely. Absolutely, you can measure. Why not? Liquid should be converted in the kg. Volume should be converted in the kg. Yes, absolutely. If you see, I don't know whether you mark or not. If you go and check your oil bottle, it may be sunflower, maybe mustard, whatever the oil is available with you. Check it out. 1 liter, and below that there will be gram. It may be 0.936, 0.956, 976, whatever on the basis of the density. Mention over there. Gram. Yes, absolutely. So there is no fixed rule. You have to think what you are doing, what type of unit you have to use. So actually the thing is that scientific notation. Because you know that it's very, very important. So you are using, if your sample is using in very little bit, so you have to use that on the basis of that. If you mention in kg or mention in that gram or microgram, you have to decide. So there is no specific rules, but it is essential. Okay. Now the thing is that some essential characteristics of the method which must always be considered are the following: the complexity of the material to be analyzed. On the basis of that, you have to do the measurement. So the probable concentration of the species of interest, accuracy, sensitivity, and detection limit, then selectivity, then duration of analysis, then cost of equipment. On the basis of this, you have to use your units, or you have to go to your unit. Okay. Next slide. The interpretation of the measurement. Actually, the thing is that these things you have to understand that that's why I set an example here. So that is how will you interpret, what is the value that whether it will be gram or liter or milliliter or whatever, that how will interpret this one. So on the basis of that, I just put an example for your reference. Check it out. So this reference is that a measurement provide information about its magnitude and its uncertainty. Consider the example. The balance, okay, that figure is there. That figure is mentioned here over, which is actually that 2.1. You just forget that 2.1. It is by mistake was there. Which is recording the mass of the cylinder. Okay, so there is cylinder. So assuming that the balance is properly calibrated, we can be certain that the cylinder mass is more than the 1.263 gram and less than the 1.264 gram. So see, there is two things: 1.263 gram and less than 1.264 gram. See, what is that? Generally, mathematically is telling 3, after 2, 3, there will be 4. So check it out, the 4 digits: 1, 2, 6, 3, 1, 2, 6, 4. Two things are there. So this is the sensitivity. When you are usually calculating that after 2 or 3 decimal, we are not using the number in arithmetic process. So like it is not like that. So that's why it is important. The result of an analytical measurement after proper calculation is usually reported in relative terms. Got the point? Relative terms. It is not actual the things, it is relative terms. That is, in some ways that express the quantity of the analyte present per unit weight or volume of the sample. Thus, the results take the form of numerical data in suitable units such as percent, parts, ppm, or some others. So usually we have to use in case of percentage or ppm in this case. Okay. Next, what is the importance why we are studying this analytical chemistry? So in the last that is what till now what we have studying, that is how analytical chemistry what kind of that process we have to use for evaluation of the that value of this any mass or anything else from of a sample. So that's we have studied what kind of samples or what type of process we have to follow. That is maybe sample, maybe that how to do the measurement of all the things. But right now, so after completion of this one, right now we have to understand that why actually we are studying this analytical chemistry. So I explained lots of things. Every technique, after the every technique I told you, where is the application of this part? What type of applications we are doing? What type of applications we of any technique, anything else, that what techniques or what that particular process method is used for. Now the thing is that we have to understand what is the value of this analytical chemistry and what is the trend emerging this situation right now in the modern age. So this is the important area where we can implement these things. What is the importance of the analytical chemistry? So analytical chemistry is of fundamental importance as is to based on the development of methods for identification, determination, and separation of the substance in different range between a measure and trace constituents. So as it implies, as it says, so analytical chemistry is to define, identifying the particular what are the composition of that product, what type of structure is there, and all the things. Then determinations and separation, how to do the separations. All the actually this is a combo pack. Analytical chemistry is a combo pack in case of chemistry to understand a compound very well in the manner of very well, that is how to understand the compound, what to do. Okay, next. So analytical chemistry is recognized to fulfill both the fundamental as well as the applied aspect of the science and technology in general and chemistry in particular. Okay, next. Andrew Lavoisier, that is the scientist, has been considered the father of analytical chemistry because of the careful quantitative analysis he performed on the conservation of the mass. Okay, so that means you know that law of conservation of mass, the mass neither be created nor be destroyed. It can changes from one form to another form. So that's why, so that means only the structure changed, but mass has not changed. How can you calculate? How can you say? In a reaction something happened. In the reaction something happened. But how can you say the mass has not changed? It is only due to the analytical chemistry. He calculated by using number of moles. He calculated what is the amount is formed and is separated. Amount is formed means that is the analytical process. What is the amount of that product is formed? That is the analytical process. Okay. So, but thinking that separation is there. So he has done a perfectly that analytical chemistry method. He has used the perfect analytical chemistry method. That's why the law of conservation mass is developed, and we follow that. Thanks to him, we should give a great salute to him that he has given such a beautiful law to the chemistry, law of conservation of mass. That's why we are very that honestly we will do that chemical equation, balancing of chemical equation very blindly. We just say yes, this is happening. Okay, now the thing is that okay, there have been three major contributions in the present vital of analytical chemistry. First thing, the flow of theory from physical chemistry and physics into analytical chemistry. See that here two things. The analytical chemistry is a composition of two things. That one is physical chemistry. One is physical chemistry. Second is your what is physics. This combination of the two things. If this happened, physics, because measurement is there, right? Without measurement, you cannot do. Measurement is there. And also, physical chemistry is there. Number of moles, chemical reactions are there. The product is formed. So that's why this analytical chemistry has actually that you have to do it in proper way. Next step is application of electronics by analytical chemistry for assembling new, faster, and more sensitive instruments. Nowadays, time to time, newer instruments are coming out. Now it is chromatography, spectrometry, lots of things are the mass spectrometry, lots of NMR, TGT, TMT, TGPA. So many instruments are there for the calculation. So that various countries are using various kind of technologies. Next, applications of computers for both data processing and automated control of instruments. It is essential. In microsecond, we have to transfer one ml of that is suppose that any reagent. After 2 seconds, we have to put that 1 ml of what is reagent. So we cannot do by our own hand. It is essential. The system should be automated. You feed that on that machine will do that. You have to only that think the process. You have to only choose the process right way and all the things. So that's why after that you can get the things in nice way. Okay. Now the thing is that if we'll come to the point, next slide will go. Things that here are some recent trend and emerging needs in analytical chemistry. So you have to understand this is the recent trend which is going on in case of analytical chemistry. So follow the steps, and after that you will check it out what kind of that things. See that better result faster. So one point is green analytical chemistry, better result faster, mass spectrometry, lab and cheap technology, portable of automated device. So these are the techniques used in case of analytical chemistry nowadays for better result and fast result. Okay. Now the thing is that let's go to the next point. Next slide. Next slide. So improvement in a data analysis and processing. These improvements have included improvements of data analysis and processing, new sensors and biosensors of the environmental monitoring. These are the important trend of environmental analytical chemistry. Detecting and qualifying emerging pollutants. This is being driven by the need of to detect the to quantify emerging pollutants such as the microplastics and nanomaterials. Analytical chemistry is a field that plays a critical role in many areas, including pharmaceutical, environmental monitoring, food safety, and forensic science. These are the things you have to where you can use. I told you the broad things, and individually I told you which techniques is used in which area application areas. So you have to understand what is the importance of analytical chemistry, what subject you have to choose. So unit 1 is completed. Let's go to the, so from my side I'll do one thing. So after the unit 1 completion of unit 1, so let's check it out. I'm sharing that that syllabus which is there with that is from IGNO. So I'm sharing with that screen, and on the basis of that we can understand that actually what type of questions are there, and whether we have that learn that questions or not. So okay, let's go to that slide only. Just a second. Now in front of you that this is the unit 1 that portion syllabus which is provided by the IGNOU. So I just finished all the things, but let me to go to the that is question side. What is the assignment is there? So let us discuss about that, and after that we'll go to the second chapter. Okay, now in front of you, you have seen that self-assessment questions. You can see that have you seen that my screen? I just have shared.
Yes.
Okay. Now this is the syllabus that is which is provided from the IGNOU side, and there is self-assessment questions. Just go through the questions. I don't know you people have that syllabus or not. So it is with me. That's why I shared with you.
Sir, we don't have.
Sorry.
Sir, we don't have the syllabus.
Okay, right now in front of you that na. You can download that one na from IGNOU site. You can download. You should have your syllabus at least.
Okay.
Okay, but in front of me, I just shared with you, right? You just go to your that is link and all the things. Your syllabus will be there. Na? Okay, this is the syllabus which is provided by from the IGNOU side. You check it out. Self-assessment questions. Go through the all questions. Actually, no need. I'll give you 1 minute of 2 minutes of time. So check it out. All that what is exactly in front of you. All the questions we have discussed or not. Check it out. Read the questions and just refresh your knowledge that whether we have checked it, we have learned it or not. A method, let me to, have you gone through all of you?
Yes, sir.
Okay, good. So that is a method to be called as an analytical technique should be based on the measurement of a property. Oh, this is the answer. Okay, these are the answer. Okay, sorry. Let me to go to the question. What is the question? Okay. So here that question 6 is who is considered as the father of analytical chemistry. Right now I told you. Lavoisier Antony Lavoisier is the father of analytical chemistry. Okay. So on the basis of perhaps I finished all the things when gravimetry analysis was developed. Okay, you will read that one, you will find out that one. No problem. The next is that what is turbidimetry and nephelometry. I taught you that one also. Where is the major contribution present in the vitality of analytical chemistry? Okay, it's already right now today we have discussed. What the mechanism involved the radiochemical methods? Already I have told you. Name the common use. Name the commonly used thermal methods. Already we have discussed and the answer is provided here over. So you can also all the methods we have discussed. So hope that so right now you will find out your syllabus from the IGNOU sites and you just go to your IGNOU that website and find out that is where on the basis of that you just find out that one. Okay, thank you very much. So let's go to the another segment of that one. Let me to upload this thing slide. Just a second. So now thank you for your attention and all the things. So we have finished with our unit 1 syllabus, right? Unit 1 is completed. If anyone has any kind of a doubt in case of unit 1, So you may ask 1-2 minutes, 3 minutes, then I'll go to the unit 2.
These are the things covered by this one.
Which thing, sir?
Covered by the books that was supplied by the IGNOU. MC02, MC0.
Mr. Kader, do you have any question?
That is why I am telling you.
Yeah, tell me.
These slides are you are covering unit 1. All the
Okay, that's fine. As for I committed, I have to provide you with all the slides, right?
Right.
So it is only for you, right?
No.
I just committed that today I'm sending. Actually, the unit 1 is completed. So today I'm sending the slide to the IGNOU director, sir, and he will provide it you through your email ID. Or else, you will tell me. Can anyone know how can I share this one?
No, one more thing. This can be find out in the books, no? MC0201.
Yeah, absolutely. What I taught you, you will find out your syllabus,
Only
right? But
slide. Right?
no. Slide is not. It is actually that all the information is not in your book.
Presentation.
Yes, Mr. Kader.
Yes.
That is
Only presentation, no?
sorry.
This is only presentation, no?
Yep, I prepared that presentation.
Yes. Yes. So.
It is not available in your that syllabus, but matter is there.
Matter is.
Matter is there, but all the matter is not available.
All the matter is not available.
No, not available. That's why.
Okay.
It is my own design and my own preparation. I can share with you all, right? So if
that one, no books, no.
no, your syllabus is there. You're on the basis of your syllabus, but it is in expand form. The slides are in expand form.
Yes.
Principle is not there. Whatever, suppose I will say that spectroscopic method, right?
Yes.
Principle is not there, technique is not there, application might be there, might not have. So I have not gone through your syllabus. I have learned, but things that it is my preparation, my creation, own creation.
Okay. Thank you.
So, but if you tell me what is the way anyone can have any idea, so I can share with you because I got the permission from the IGNOU, so I can share with you all the slides. You can take it out. But thing is that on the live class, how can I share that anyone has any idea who can help me out in this case? Right now I can share.
Okay, no problem, sir. Thanks.
So any dear students, do you have any idea that how can I share these slides right now? Is it possible? Can you give me idea that how can I share with you? Chat box or something is there, right? Mr. Iqbal, do you have any idea?
Yes, sir.
Yeah,
No,
tell
sir,
me.
but there is no sharing options are not available there, sir.
Okay, no, one chat box is there, sir.
Yes, sir.
Just a second.
The chat box is there, but whether it will be seen or not, not answer.
Okay, so
There is no option for attachment.
Okay. You may try passing the interlink here in the comment section. Okay, some student enter the link. Okay, let me see that one. How the link I will send? Sorry, I can't.
Can take.
Tell me how. What is the procedure? I Sumanjit, I can't hear you properly. That's breaking. Link appearing at the top. Okay. Link appearing at the top.
Screenshot.
Can you tell me that where I have to go? Screenshot. What is that? Screenshot. Okay. Students can take the screenshot. Okay. So all of you can take the screenshot right now. Can you take, if I'll share my screen and can you take the screenshot?
Yes, sir.
Okay. So right now I'm going to my screen. I just, Okay. Right now I'm going to the screen. Okay.
Sir, as you told that you will be sending to the
Yes.
coordinator, and yes, he
Yes.
will
Yes.
provide
Yes.
it to
That
you.
is
No?
that is that is that is
That
correct.
will be fine. That will be fine.
Oh, okay. It will take 2 to 3 days to reach.
Sir,
Actually,
no problem, sir.
okay. That's
Actually,
actually that.
in general, material is there in our book, and
Yeah. Absolutely. Absolutely.
your presentation is very broad, and it will help later after reading this book.
Absolutely. Absolutely.
So it
No, that
will,
is
if it will take
that.
2 or 3 days, it will be, I think, no problem.
Absolutely. What I told you that I just spoke to the IGNOU director here, so that he told me you send us that we'll send to them all the students over the that email ID, right? That permission I got. So actually that I have not finished today itself. I finished my unit 1, so that's why I have not shared with him. Today itself I will share with him right now after my class.
Okay. No
Okay,
problem, sir.
so that will be fine, and you will get in the PDF format of that all slides. It will
That
help
will
you
be very
later.
helpful, sir.
Okay. Okay, that will 2 to 3 days. The chapter will not means complete. My portion is not completed. Okay, so okay, so thank you very much for your cooperation. But thing is that we'll start itself unit 2 today, right? I'll start unit 2. Okay, so let's go to the unit 2. Okay, I just shared the unit 2. Are you getting it?
Yes, sir.
Okay, good. So that is unit 2 is important. That you must have some question that sir you are telling that all units are important because you are the future of the country. So that's why. And you have choose such a topic that it is most important thing, that being a chemistry person, really it is a actually I yesterday also I told you, last class I also told you, it is from my side I should be appreciative to all of you to choose a career in this field. And it's you are studying means you have to choose the field. Okay, so that is evaluation of analytical. So itself name is somewhat is there, and data 1 is there. So this is the today is the lecture 1. Understand that is see that evaluation of analytical things. If we read this unit 2 name, chapter name, that evaluation of analytical data 1, so it a little bit actually I don't understand. Okay, so let us understand that introduction of evaluation, objectives, error and types of errors, etc. in this chapter. So in front of you, I, Dr. Pratap Bhatpanda, so that present this topic in front of you. So hope so you people have understand the techniques, that methods and principles, all the things in the unit 1. Let's go to the unit 2, and this is completely practical based. You have to understand all the things. Where it actually we are going to some difficult level right now. We are moving towards some difficult level because you have there is a point error and types of errors. This is the actually the most. Let's go to that. Just a second. Now the thing is that a chemical analysis. What do you mean by this? Evaluation analytical data 1. So in the introduction, I want to say this thing. A chemical analysis is usually more than the simple measurement. It is not. It is not the measurement. I will it will just link with my unit 1 last slide or 2 before the last slide, it will connect. So how it is, it will be in the ppm, not in the, it is maybe in the percentage, maybe in the, that's why mass percentage is there. So it should be in percentage or in that is ppm, not in gram, not in liter, not in liter. This is the okay, this is the initial thing, but ultimately we have to fix the issue by means of using ppm or that percentage. So that's why now I'm going to say a chemical analysis is usually more than the simple measurement. It's not a simple measurement. Measurement, the operator mainly takes care of 3 components. When you are measuring anything else, you should be careful about 3 components. Dear friends, you have to understand how the importance of this measurement is there. Lots of things are there in measurement. Okay, the system, you should be think about the 3 components. One is system, which system you are using, that is mass spectroscopy or titration or nuclear process, what type of procedure you are maintaining. You have to understand. Second, if the system means it is in liquid form or in solid form or in gaseous form, whatever that is completely under the system. You have to understand that. Second is some property big. You have to understand. See whether it is a properties means suppose that it is diluted in the water or diluted in the acid or base, whatever that kind of a properties or something else like that. Then measured and the instrument, what type of instrument you are using, that should be. Next, errors originate in all 3 components. Absolutely. So most area when I started my teaching here, so I told you errors and types of errors. Everywhere there should be error. Will come across. Will come across. What type of errors are there and how we'll fix this one. Okay. And need to be considered in a measurement. It is a real fact that no single physical measurement is perfectly accurate. You will say person A and B both went to a vegetable shop and purchased cauliflower. Person A purchased cauliflower, person B purchased cauliflower from the same shop, same vegetable vendors. Okay, I want 1 kg of cauliflower. A want 1 kg of cauliflower and B also wants 1 kg of cauliflower. But the vendor when will give you that maybe 999 gram of cauliflower, it's not equal to 1 kg. Maybe give you one, B got 1 kg 0.006 gram or 1000,006 gram. So some discount. You paid same amount, A paid same amount, B paid same amount for 1 kg of a cauliflower, but A got little bit less, B got little bit more. We don't have any complaint. We take and came to our home. But that should not be considered in case of your chemistry. That is loss. Okay. Next, it is a real fact that no single physical measurement is perfectly accurate. The purpose of this unit is to provide sufficient information to the students to enable him to examine the factors affecting the reliability of results and reliability of the results and understand the contribution of errors and their types, their minimization for the accuracy and precision of the measurement and the proper use of significant figures. I told you that several times you heard about that one term is significant figures. Significant figures. You heard about the several significant figures. several times. You have to understand what is the significant figure means. Little bit work out on these significant figures, how it is happened, what is the decimal point, what which will be considered. Suppose 1.005, then significant is 4, 1.005. But suppose 1.500, so only two significants are there. 00 will not consider. Lots of things are there between the significant figures. You have to understand, you have to little bit work on that. If you go to the next slide, then what is the objective of this? What is the objective of this evaluation analysis? After studying this unit, you should be able to understand error and the types of errors, in the measurement. Second, known the distinction between the accuracy and the precision. Express the final results of a measurement. Next, find the proper use of significant figures in the measurement and calculations. So these are the objectives of these chapters. You have to, so as the thing is that whole chapter is based on the error and error facts. So we have to be careful about this one. Next. Okay. Next, if you go to the then error and the types of errors. This is the numerical area, so that's why be careful about this thing. The data obtained by physical measurement should always raise the question of error and their nature. Various types of errors are caused in quantitative chemical analysis. Quantitative chemical analysis. Error is mathematically defined as the difference between the observed value and the true value. Here, observed value is denoted as the O, and a true value is denoted as T, and E is the error. Where E is the error, O is the observed value, and T is the true value. Now, if we take the example, if you see an example here in front of you, that let us consider, for example, for the capacity of a measuring flask whose true value as given by standard measurement is 250 ml. For a series of 5 measurement done by the analyst, the error is represented in the table. Okay. So now don't make it complex. Don't think it's complex thing. Okay. You have to understand. What I'm going to say, same thing I told you about that vegetable vendor. I told you. So like that, a thermoflask means flask having the capacity of 250 ml. Right? It's the capacity of 250 ml. But thermoflask. 250 ml is the capacity. Okay. But the person A, if you say 1, 2, 3, 4, 5 observer, right? So the observed value is, what is that? Person A fill 249 ml in that bottle, but the capacity is 250 ml. So that error is minus 1 ml. Got the point? Person B fill that on 247 ml. 247 ml. Sorry. So person B filled 247 ml, but still the capacity is 250 ml. So error value is minus 3. Person C or third person filled 250 ml. The capacity is 250 ml. So that means error is 0. Got point? What I'm going to say? Don't be confused. So this is not typical thing. You have to understand the thing, understand the facts. You have to understand the facts. Person 4, that is the capacity of the flask is 250 ml, but it's filled 248 ml. That is the observation value. This is the true value. The capacity is this, but we have that person filled 250 ml, 40 ml, 230 ml. Okay, so that is means error value is 2 ml. That is, I represented the minus error value. That's when decreasing value. Okay, so person 5, so 251 ml is overcrowd, but the capacity is 250 ml. Okay, so you say, sir, bottle is 250 ml, plus is 250. How can you say the 251 ml? Because there is little bit gap there. So you have to consider that one. Okay, but see, it is not about thermoflask. It is about that a beaker, 500 ml beaker, but we have to fill. So if you have done that, what is that? Let me to explain this fact. You have that pipetting. That the vex part of should be in that should be tossed to that line. That is perfect pipetting. But we people do what? So vex part should be in the down, but the cape part should be tossed to the that particular pipette line marking. So that is the mistake. That is the mistake. That's why automated systems are used right now. When I was doing in the lab of IIT, so we have done lots of automated system process. To get the accurate value, you have to do automated system. But manually, if you do that one, there will be error. So that's error I am saying you. So now the thing is that what will happen here? Total, if you see, that total minus 5 will be the what is error value. Error value will be the minus 5, minus 1, minus 3, minus 0, minus 2, plus 1. Total minus 3, minus 1, minus 4, minus 2, minus 6, then plus 1 is minus 5 mm. So now the thing is that, but average value
acceptable.
Sorry?
Error is 1%, 1 or 2% acceptable. No?
That we are coming to it is simple things I gave you, but if the number of error will be more, that is why you are using significant figures.
Normally, the tolerance level is it is 1.
Yes,
1
yes,
to 2% is allowable.
absolutely. But actually, if in the real base, some segment are there like pharmaceutical industries. So we have to maintain some at 1%, not more than that 1%. It's absolutely correct.
Yes.
Absolutely correct. Okay. Now the thing is, that's why I'm going to say, but we have to find out the average value. So average value means minus 5 and 5 times observation we have done, then minus 1. That minus 1 ml is the average value. That's the average error value. Okay. So that is that what Mr. Kader told, that it is acceptable. Yes, somewhat it's acceptable. But automated system, that this is happened in case of manual system, but automated system, if system is perfect, automated system, so this kind of error may not be arises, but somewhat 1% error in my consideration, what he told that if I'll consider that 1% is okay. So next, if you go to the point, however, the absolute error is a little practical significance for your quantitative analysis. Okay, so that means it's very little. What Mr. Kader told, that is correct thing. It is the relative error. That is the error relative to the true value expressed in suitable units is of the practical importance as the measure of inaccuracy. It is convenient to express relative error in terms of percentage or ppm. So that's why I told you. That's why. If it will be in the percentage, so that means 0.1 or 1 will be what is the 1 ml will be that error value, or minus 1 will be error value. So percentage will be 100%. Accuracy will be 100%. 1 ml should not give much more impact on the calculation of percentage. It's very that what Mr. Kader told. That's absolutely correct. So now the thing is that To understand the importance of a relative error, let us consider the measurement of the capacity of a 3 standard flask 10 ml, 100 ml, 1000 ml by 3 analysts A, B, C respectively represented the follows. So analyst A, B, C. Analyst A has taken true value is 10 ml, observed value is 11 ml, and error is 1 ml. Analyst B has taken 100 ml true value and observed value is 101 ml, then it is 1 ml. Analyst C has taken 1000 ml observed true value. So it is important, you have to understand these things. Mr. Kadar, what he told that now you compare with this one, then certain things will be there, right? So my point is, it is here, sorry, that analyst C has taken 1000 ml and observed value is 1001 ml and error is 1 ml. Now relative error is 10%, relative error is 0.1 in case of A, in case of B is 0.01, in case of C is 0.001. Now the percentage in case of A is 10%, in case of B is 1%, in case of C is 0.1%. Now if 10% error will be there, will it be considered? Not at all. That's the mistake. And it's a blunder. So we have to understand. We have to, you know that this is actually very simple arithmetic calculation. Very simple arithmetic calculation. But thing is that the first case, if the true value is 10 ml and observed value 1 ml, very true value is less, very less, 10 ml. But observed value is compared to the 1 ml. 10 ml gives 1 ml. Mistake. So that's why it's 10%. So 10% should not accept. It's a blunder in the chemistry. But okay, as Mr. Kadar told, we can consider that analyst B and C facts 1% and 0.1%. 0.1% is the 100% accurate. There is no issues. But 1% somewhat there is issues. We may consider. But in case of so many things like your pharmaceutical industry, that space research and all the things, it may not be considered, right? But 10% is blunder. So we should be careful, as you know that your sample size is very small. Your sample size is very small because we have to test the sample in several steps. We have to apply the sample in several techniques. We have to apply the sample in various technologies. Then we can consider the things. If sample size is small and the relative error will be little bit high, or means observed error is little bit high, then absolutely the percentage will be higher. That is why this is important. Error. So 10% error is a blunder in case of chemistry. 1%, I do say that 1% is also, but okay, we can consider in some cases. That should not be known as the concentrated. Okay, that is why. Okay, if we come to the next point. So types of errors. Practical point of view, it is useful to classify errors into two categories. One is determinant errors. Second is indeterminate errors. So this is somewhat technically something is there. Hope shall we continue that we'll read this determinant, or we'll stop the class today? It's around little bit 15 minutes are there. Okay, any people has any questions? Actually, that this facts is connected with another facts, so it will take some time.
Sir, continue.
Okay, that's good. So thing is that, let's go to that determinant errors. Or determinant errors is in analytical chemistry is an error that could have been prevented by the changing how the experiment was carried out. An example of the determinant error is the instrument not being properly cleaned or calibrated. See, you people have done lots of titration. Why am actually that thing is that this is the process. You know that you have done that. In titration, titration is the method. Means we'll do that on that practical. Titration means before titrating the things, your burette and the pipette should be rinsed. Have you done or not? If we think about the 10+2 system, that you have done the titration. So KMNO4, that you will titrating that KMNO4 with oxalic acid. So you will put the KMNO4 in the burette, then you will rinse. Isn't that it?
Yes, sir.
Yes. Why? Because the impurities should be cleaned up. Impurities should be cleaned up. If without rinse or properly rinse, if you have done the titration, then what will happen? There will be the impurities. That will give the bad result. Isn't that it? So that should be done a proper way. So that is mentioned here over. So determinant error means prevented, properly cleaned or calibrated. Sometimes what happened, I have seen the students will do the titration, but the air bubble will be there in the at the end point, right? Air bubble. What will happen? If we do not pass the air bubble, that there is a difference between two, means that a solution. KMNO4 between that there is a air bubble. So what will happen? That will come down. That your ml in the KMNO4 use will be maximum. Then there will be error. You should be careful in this case. Next, some examples of determinant errors include instruments not being properly cleaned or calibrated, uncalibrated balances, improperly calibrated volumetric flasks or pipettes, malfunctioning instruments. You have seen that sometimes that burette is not properly flow the liquid. Okay, that nozzle is not working properly. One drop is coming the smaller size, second drop is coming the bigger size. So then your pink color may be more, light pink should not be absorbed. That's the issue. Next, impure chemicals. If your chemical is not perfect, then the behavior of the chemical should be, if it is not belongs to the good quality, then reaction will be not occurred. Whatever may be the things, that will not perfectly done. Then incorrect analytical procedure or techniques. If you are not doing the sampling perfectly, if you are not maintaining the proper procedure, if your electrical current is not steady, so the result will be bad and your experiment will be failed. Your sample will be destroyed. What I meant to say, then analyst errors. I am doing the titration. In between that, my phone was ringing. And I picked. So titration is gone. Spectroscopy meter is gone. Right? Current supply, I have to supply for 1 minute or 30 seconds. So in between that phone came. I picked the phone. Right? 34 seconds. Current supply I have done. Then I switch up. What will happen? Entire procedure, entire experiment will give you a big zero. That is the sensitivity matter. This is the error. Next, if we will come to the determinant errors, what is the source? Exactly where, due to what kind of a source is responsible for this kind of error? The analyst or operator You can say, or it's known as the personal errors. What I told you right now, the personal errors. People, I am not telling that that we people are using the mobile in the lab. Actually, in the lab, mobile phone is not allowed. But just I give a phone example to you. Sometimes it happen. Okay, but this is the thing. The analyst or operators or personal errors, which is responsible source point. These errors are caused. These errors are caused due to the constitutional inability of an analyst to make the certain observation accurately. You people have done the same thing. I'm coming to that because that other experiment you have not mostly done, or in graduation salt test you have done, whatever maybe. But titration you have done in the degree, also in the 10+2, and also this is the classical method. Titration you have to do in this case of PGDAC course also. So if that you have to find out the light pink, you don't know what is light pink. You are thinking that light pink is a pink color because my faulty ideas and all the things, faulty determinations. I keep this is pink. Okay, I have done in the lab, in the college lab, that is this pink is considered, and I got the full mark, 10 on 10. No dear. You should know what is the light pink. If you put that glass in front of the light and you just shake little bit shake, so sometimes you'll observe transparent, sometimes observe just a slight of pink. That is light pink. But I mean to say, I am explaining on the theory, so that's why. But practically, if you see that, if you keep in front of that glass, that beaker or that test tube, whatever maybe that light pink you have done, so that particular thing you will see that it will shake in the light, in front of the light, so little bit twisting, and that you will see sometimes it is transparent, sometimes it's just a blink of pink. That is what you say the. This is observation. And if you see the steady pink color is there, that is wrong. From every side, you will see that a steady pink color, there is no transparent observation is there. So that means your experiment is completely wrong. So that is the personal error, or person-based or analyst-based errors. You have to understand that one. Next, we'll come to the point, the equipment and the laboratory environment or error due to the equipments. I told you that we have already discussed. It will not properly range. If you are using that voltmeter in a that is a faulty one. If you are using that any kind of balance machine, you are wasting some 3.14 gram of that is oxalic acid, but that balance machine is wrong. It's a faulty one. So your experiment will be wrong. Okay. Now the thing is that the method or procedure or errors due to the reagent. Okay. You have to prepare. You have to evolve the. Suppose that methyl chloride is given. You have to make it. What is that? Alcohol, methanol. What kind of reagent you have to use? Is it sodium hydroxide? It is potassium hydroxide? Is it water? Or it is hydronium ion? Which is the best one you have to use? You have to think itself. Whatever analysis steps, procedures should be, you should use, you should understand that and before. You have learned in the last several years of your studies, you have learned so many things. So reagent, choosing of a reagent, which reagent you have to use, for what procedure, what time the reagent should be used, and what kind of a reaction you are doing. It is acid with base or acid with you are doing acid with acid. Acid with acid, nothing will happen. Base with base, nothing will happen. So you have to understand that thing. Okay. Next slide. Okay. So today we have to finish, and next is operational errors. So in the next class tomorrow, we'll work on this operational errors and all the things. Okay. Thank you all. Do you have any kind of if you any kind of questions, so you can ask me.
No, sir.
Okay, thank you very much. Thank you very much. So I am just sharing within some few seconds of time or minutes of time. I'll just share this slide with that IGNO. So they will provide you all the slides in the unit 1. Unit 2, I will not provide right now. Unit 2 later. Okay. Thank you very much.
Thank you, sir.
Okay.